what is happening around the world in technology. Like in this AI world, every day feels like a year has gone by with new things that are coming in. So it's really hard to catch up what all is happening.
This breakthrough by by China basically busts the myth that US or America innovates, Europe regulates, and China imitates.
In India, things are changing a lot now. I personally think that ambition is being driven. What I personally see is that these coding-based LLMs are going to improve more and more in the coming years.
You want to give LLMs enough rope so that they can do interesting things, but not so much that they can hang themselves. MCP is more of an exercise in social engineering than software engineering. But in the next decade, a lot of content produced on internet will be not for human consumption, but for agent consumption, or like AI
Crawlers,
agent
yeah.
consumption.
Looks like doing deterministic things and doing probabilistic things will actually find a balance.
It's a interesting time to be alive, to be honest, and be a developer.
Welcome back, Amit. Today we have a special guest, one of the people that I've learned a lot from, one of my favorite dev revelers, as we call our employees. Somebody who is an avid learner, extremely down to earth, humble, and somebody who's really I would call an anchor to a lot of the innovation that we've done as well. His name is Harpinder Singh. We call him Happy. He's literally a very happy person. So we'll probably get to see some of that today as well. But welcome, Happy, to the show, and I'm honored to actually have you and basically talk to you about a very favorite paper of yours that I also got to read to prepare for this podcast. We'll get into some of that. We'll talk about your life, a little bit about what you did before this, and when you joined DevRev was almost 4 years ago. So literally the company and you and us, we've all grown together here. And then we'll get into the paper, talk about CodeAct, which is something that came from Apple, but looks like there's some precursor to that would be worth comparing. Amit, any initial thoughts?
Yeah, no, welcome to the podcast. Happy. Looking forward to learning from you. And,
Great.
to get us started, maybe tell us a little bit about yourself and what gets you really, really fired up.
Thank you, Amit. Thank you, Dheeraj, for the warm introduction and invite to the podcast. I'm really honored. So, hey everyone, I'm Harpinder. I graduated in 2021 and joined DevRev as my first job and have never looked back since then. Uh, it has been a up and down journey that we have seen in DevRev, but it's been an interesting one. Right now, I work on AI in DevRev. Before this, I was working on workflows. What excites me daily is just to learn what is happening around the world in technology. Like in this AI world, I switched around 1.5 years back, I guess, and it has been a like every day feels like a year has gone by with new things that are coming in. So it's really hard to catch up what all is happening, but it's really interesting to see the wave that is being going on with all these LLMs, function calling, MCP, and whatnot going on all around. So yeah, it's a interesting time to be alive, to be honest, and be a developer.
Awesome. Uh, Happy, tell us about your like where you grew up and tell us about your college days and what really gave you the love for computer science.
Right. So I was born and brought up in Shahjahanpur city of Uttar Pradesh, India. Um, and after 12, I took a drop year and then joined BITS Pilani. To be very honest, like I did not have very much idea about what all colleges were there, what all were like really interesting ones. Uh, it was like, as is a dream of every Indian, you can say, going into IIT, and doing computer science. Many people have that. So I had a similar dream, and then switch happened to bits instead. But it was a really, really interesting experience in bits, to be honest. Like you are surrounded with so many smart people, not just smart in study sense, but in every aspect of life. There were clubs, there were activities that keep going on every day. I'm not part of a lot of them, to be honest, but yeah, like college was a very interesting time for 1.5 years or so, after which COVID happened, sadly, and we had to shift home. My last 2 years were work from home, you can say. But nonetheless, like I still miss those college days. Even I thought of, for example, going to masters at a point in time just to relive the college magic, you can say. So, but yeah, like the job kept me awake, and I thought it's like maybe not still the right time for just starting again that education piece, because I thought like learning hands-on here is giving me much greater advantage than just going back to those textbooks and studying those aspects. But yeah, it was an interesting time still in the
I'll
college.
pay you on the side, by the way. I mean, honestly, none of this was actually fed to him. So thank you so much for saying that. Um, obviously you spent like 2 years at home the last couple of years of college. Um, like, how has coming to Bangalore and being with a bunch of peers and young people, because we hired a lot of young people as well, and all we expect of them, obviously, to learn from them because they're faster learners, and as we'll see in the podcast today, that people like you are learning so fast, I'm barely keeping up. But we also expected them to nail the things that they were doing. Like, they just nail this, and you don't have just constantly look for the next thing. It's like, well, if I nail this, I'll get noticed. And when you look at just the way you milled around with the community of folks that were around you, how was Bangalore like, in the initial year or so?
Bangalore was really great. I'm not sure if it's just Bangalore or just going out of home. What was the difference? But uh, it kind of brings a lot of responsibility at like even after 12th, when you go to college, things change, independence comes in, but still a lot of things are okay. There is a mess, food is already there, there is a like clothes and all. Most of the things are already taken care of. Like there is a default process that is going on there. But when you really move out of college life and join a job anywhere, I guess, then the reality starts. You have to take care of electricity bills. You have to take care of washing clothes and all those things. It's not like I don't. I hate that, but it's just that it was all new starting when I came to Bangalore. But it that has also been an interesting experience, I guess. Like personally, I think I grew up too fast age-wise. As in, people call me like I'm kind of living my 30s. As in, I wake up around 4:30. I go to gym at 5. My day starts at 4:30 and at 9 or so. But yeah, but in Bangalore, I found some good people. And the environment is really interesting. I mean, there is always a FOMO, although that in Silicon Valley it's much different, much better. But like recently, I even got to visit there. I'm not sure if how much of what I thought and how much of that was reality.
Mm.
But
Yeah,
anyways,
say more on that, because one of the things interesting, AP, I didn't tell you, Amit, about Happy, whether we are rhyming AP and Happy, in today's episode. was that he had an option to move to the US, Austin, Texas, or even the Bay Area. But he actually thought about it for 6 months to a year and he decided not to. I mean, that's a very interesting sort of thing. So say more on that decision as well, because obviously there are people on both sides of the aisle who are listening to this podcast, and they'd love to hear from somebody who's young and youthful and aspiring. How did you think about this whole thing?
Maybe I'm not sure if the decision was right, or I will just get to know that eventually. But my thought process was there were multiple factors involved there, but the major one I felt was like previously, like why was that kind of FOMO or a desire to move there was because that's what I've seen so far, what people have done, what my seniors had done in college. They just like, for example, after 2 years, like most of the people go to masters and then take a job there. So now there are multiple aspects to it. One is like even in the US, the visa and all situation is not really super easy and great. But I was not too much worried about that. But the main thing was like what I was seeing was in India things are changing a lot now. Like it still isn't there, obviously, but there's a lot of tech advancements happening in India, as in many like big firms which used to have their office only in US or like not in India, now they are moving to India. So there's a lot of like good tech talent that is staying in India, and there is a high demand. That is one thing. And even the VC money and so on is going. Again, I don't know much about it, but this is what I've seen. I've talked to people. So it didn't feel like right now is the great time to move to US. Like someday I might want to, for example, start some of my own thing. Then might be the actual time to be at a place. For example, it said that you should be where your audience is, right? I mean, what you're selling. So that might be the right time. But right now, I think I'm at a great place. Yeah.
Thank you. AP, anything else to add to this?
Uh, no, sorry.
Well, I think, by the way, your hairdo looks very much like Einstein in the backdrop. I'm looking at you. Or you're trying to ruffle it up like that, right now as we speak. I had one question on India, and this relates to that article I recently read, like maybe 8 weeks ago, when DeepSeek came out.
Mhm.
Happy, and maybe Amit, you should also chime in. So there was a really interesting sentence. It said something like this breakthrough by China basically busts the myth that US or America innovates, Europe regulates, and China imitates. It's just turned upside down in a very big way. First of all, open sourcing and all this stuff is actually a big deal. Many of the things, not the code itself, but at least the weights and not the data, but the code and the weights. What does it mean for India, Happy? Like, do you think there is enough sort of patience and tenacity to build a DeepSeek like thing in the coming 2 to 3 years, or are we 10 years behind?
I think it's the pace at which things are moving, and not just US, everywhere. 10 years,
Seems
it's
like
kind of
something.
unimaginable what would be happening.
But in terms of ambition, like, hey, we
Yeah.
got to really cut through DeepSeek as well.
Yeah, yeah. I think there's no shortage of ambitious people in India, but that fusion of capital and ambition, um, I I see it in pockets, but I'm still not seeing kind of that approach of saying that we are okay burning, I don't know, 10 million, $100 million in search of something new.
But even before that is I'm okay burning 5 years into a PhD,
Yeah, yeah,
right? Working on something. Because, the idea of jugaad is to actually find hacks to everything. But sometimes you just have to go into this abyss, as
yeah.
Bipul was saying the other day, and look into the abyss called the PhD program, which I know you have gone through. Like, you're probably one of the people who's constantly, taken that whole thing to the next level in the last 20 years. But what do you think, Happy?
I personally think that that ambition is being driven. People, like for example, again, someone I saw on Twitter. There is this guy called Paras Chopra. I'm not sure if you guys have heard of him. He recently sold his company Wingify, and now like he runs a hacker house kind of thing in HSR in Bangalore, where it's basically same thing. Residency program for a 1 year. You don't have to worry a lot about anything else. It's kind of like hands-on PhD, you can say. Basically, you come, you do deep research, and you will be taken care of. You don't need to worry about, oh, how will I get money and things like that. And so, again, it's a very small initiative that he has started. But I guess that's the kind of people we want, like who can really put that kind of investment and not like take that big bet that okay, people can really drive that kind of research even from here. Because like even if you see many people go from here to US and so on, and then they do similar kind of thing. Why? Because maybe I'm not sure. Probably because they see that okay, there's a lot of they are paid well there, and here maybe not so much for the same kind of research. But if that changes, for example, I don't see why not we can get the similar
Well,
thing here.
I give this sort of tacky analogy of what the paper even talks about: user, agent, and environment.
Mhm.
So the PhD advisor is kind of the agent, and the environment is the environment. So you need all three to actually really work together, really create awesome research. But thanks for that answer, and I'm really hoping that there is a deep seek coming out of one of the cities too. Uh, Maybe shift gears a little bit and talk about one of the things that at least I've been thinking a lot about, especially because the architecture of DevRev is you know federated agents versus let's call it, for lack of a better word, integrated agents. So what do I mean by that? In one case, you actually bring the data together, what we call the knowledge graph, and the identity together. So you dedupe identities across systems and things like that. You understand permissioning better because the identities are there, the ACLs policies, all these things are there as well. So that's basically the integrated approach versus the federated approach where you leave the data in the legacy systems. And now with MCP and function calling and all these things, or even writing code on the fly, you're actually going to legacy systems. And maybe in runtime, you're going to n number of them, maybe 10 of those or something like that to get some things done. I have a bias towards integrated systems. I feel like when you integrate the data, you actually build reliability, low latency, you have consistent APIs. Even function calling is way easier because now the LLM understands one endpoint to say, look, I think I know how to really traverse this and reason on this and things like that. So what do you folks think? I mean, maybe Amit, I'll start with you and then have Happy chime in.
I think it's very similar to the debate we've been having for the last 20 years about federated databases, right?
Mhm.
There's there's always a few companies kind of building some reasonable sized business around like, okay, you leave your data in these different systems and we'll give you a virtual database on top and you can run your analytics on top of it. Um,
Like
almost
Starburst was that, this whole Trino architecture was like that. And
yeah,
it hasn't taken off, honestly.
yeah, yeah. So what I see is that the moment something becomes important enough and frequent enough, you have all the motivation in the world to bring it in one place so that you get better experience, faster latency, lower cost. But it's very valuable for the exploratory phase,
Mm.
things that you are not doing frequently enough that it's worth paying that upfront cost of bringing everything together, setting up EDS.
Then if you're doing a AI experimental project or something, it's one thing. But the moment you're running it in production, 5 nines, availability and understanding security to the core and making
Yeah.
sure there are no breaches and things like that.
And the other thing that people struggle with in this federated versus centralized argument is the
By the
freshness
way,
of the
it's
data.
different than centralized because you might not be the primary on a lot of data. Like when we bring in Salesforce data or ServiceNow or Atlassian or whatever, we are the secondary.
Hmm.
So if anything, we are using indirection and caching
Hmm.
to solve the problem.
Yeah.
And I think there's a core belief that even for search, for example, I get better economics because I don't need so many SaaS licenses
Hmm.
when I bring a account object or an opportunity object or a ticket
Hmm.
object. Because on clicking it, just the way Google search would produce results,
Hmm.
I don't have to go to that original system because now I need a login to that system. First of all, it's disruptive.
Yeah.
But secondly, I need as many SaaS licenses as the
No,
number of search users.
this plays out all the time. Like I see that like the customer success or support people have like a Service Cloud account, and the developers have this Jira account, and they want to know like what is the customer saying, what's there in the ticket, and then they need to go ping a support guy to get the details instead of directly logging
Yeah.
in.
And now it gets worse because we are giving them the hope that search is working. So might have indexed metadata and actually put them in vector databases and inverted indexes. But now when I need to go to the object, now I have to really find a SaaS license to go there or something. In general, I've seen so many, even in the world of data management, there are all these layers that would abstract things out. So we'll talk about MCP at some point when we go through the paper, but Happy, any other thought on this?
So I guess you both covered a few, and also the business aspect of it on the licenses fees, for example. If I cover one technical aspect, so like I do see some pro. One pro which I see, for example, is let's say you are a platform where your users reside, then you have a lot better activity data of the users to be able to decide for a query for a user persona what is the most relevant object as long as user is on that product. For example, let's say Salesforce, right? Let's say Salesforce takes that data into account to power its search. Now when the user searches for something, the ranking could be, for example, much better. But if you have brought that data in but you don't have that activity data, and you are, let's say, not the platform where users reside, you are just a search tool, if I must say, for a lack of a better word, then it's hard to provide that kind of relevance. Although there is a counter argument to it, that when you bring in data from multiple systems, then you can take signals, like, because if you map it all to a single language, right? And then you can take into account cross object relevances. Oh, since this user likes or interacts with this issue on Jira, and this issue seems to be most relevant to this case, or this ticket in Zendesk, so maybe they also might want to see this ticket when they're searching for it. So that kind of cross relevance you can only be provide when you have all that data indexed at a single place, because in federated now you are on the mercy of what kind of search that system provides, and it might not provide. For example, some systems don't provide semantic search, or similarity based search. Now based on just keywords you can't provide that good enough relevance. So I do see some pro, but mostly it is pro on the single language. And even for the LLM world, now you have to just teach it one object model then and different object models. And if you can talk
For
in
reasoning,
single
yeah.
language,
Yeah,
If you
go
can
ahead.
talk in single language, then you can like generate code, generate SQL, whatever in that single. Okay, these are only the 20 objects you need to interact with, not 20 per different source which might come in. And
Yeah.
if you can solve that mapping issue, that okay, how do I map every object from every source to these 20 objects, then you have cracked the code basically.
And honestly, with mapping used to be much harder in the past because you didn't have LLMs. But now you can go pretty far because semantically there is a way to do this. I also feel like in the past, relational databases were the only place to bring data together. And now you have to worry about the rigidity of SQL and relational databases at large, But when I think of knowledge graph, it's not just a SQL database. You're talking about a graph database, it's much more flexible. You can use links, which were, by the way, a very different kind of a network database is what we used to call them back in the day. Obviously, now they're called document databases, but I think it's a lot more flexibility in forming linkages and connections and so on. But also inverted indexes, vector databases. To me, all of these are data structures in which you bring not just in one data warehouse, which used to be much harder. You'd worry about master data management, column descriptions. People are not good at descriptions and things like that. UML schemas and things like that. I think shoving it all in one centralized warehouse was probably also not very flexible, but also not very open because you don't have, let's say, a compute engine other than a SQL compute engine. So you couldn't express workflows and things like that in these systems. So yeah, I think we'll probably have to write a lot about federated versus integrated, over the course of this coming couple of years as well. Any final thoughts on that, Amit?
I think it's definitely exciting. When you can integrate things, it's really powerful, but exciting that like how it's becoming easier and easier to sort of bring information from multiple systems with little to no effort. And so, like, even though you may have like integrated 10 different systems in one place, the fact that you can have one interface through which you can query hundreds of systems and bring the data together is very, very exciting.
Well, so this is a good segue because I think federated systems would have done a lot of function calling, but I don't want to go too deep into function calling. I think this is a good sort of point in the episode for you to just go through a little bit of the history of just pre-training, post-training, talk about how function calling emerged, maybe even cite some papers that you've been reading. So over to you.
Okay, thanks. So yeah, so maybe I'll start with very basic intro of like LLM pre-training, post-training, and then move on to function calling. So for the listeners who are not very much aware or might not have seen previous podcasts, so an LLM or as we call it, large language model is basically a transformer neural network which is trained on very large portion of data, entire internet you can say, and it is trained for completing next tokens. You give it some text and it produces text after it. So there is a like token versus word versus character that comes in basically at the tokenization layer, which is basically how much expressivity you can get versus how much burden you are putting. As in with the same so with the same context, you can get a lot more information if you are outputting it at, for example, word layer. But at word layer, then you have a lot of burden because there are huge amount of word that are available. That's where the tokenization piece comes in, where it is mostly at a subword layer, which also has some other benefit, but we can leave it for now. Then we have like how LLMs are trained. I said about it's a text-based input, text-based output, but technically, to be technically correct, it's just token, which can actually be in any modality, but majority of it has been so far text. So, and for our discussion today, we will just stick to text. Then how LLMs are trained are these two stages, more or less, pre-training and post-training. In pre-training, you are learning that statistical model of, okay, what's the next token? What's the next token? What's the next token after this text? This is basically the next token prediction problem that the models are trained on. But this, after this stage, they are not good at following any instruction. So if you follow any release of the models coming in, they generally release it in two variants, base and instruct. We will come to instruct, but base is the model which comes after pre-training, for example, and you posted a question, it might just keep completing that question, not even like start answering it, which you expect. So that's where this it started from the Instruct GPT paper from Chat GPT from OpenAI.
So go slow on that. Which paper, and then we'll probably have a link to that paper in our comment section as well. So go slow on that paper.
Right. It started from Instruct GPT paper from OpenAI, which basically provided this recipe of how to train these models for instruction following. This second, so we discussed the first stage, pre-training. This second stage is called post-training, where you train models for instruction following. If you ask it a question, it must produce an answer. And here there are multiple different aspects you train the model on. What other is like human preferences alignment. Okay, you should be helpful to human. You should not, for example, abuse them. You should not speak ill when you're replying. So here, for example, now the techniques are changing, but the most common technique here was RLHF, reinforcement learning with human feedback. We will link the paper to that also in the show notes. So with RLHF, I'm not very much aware of the maths of reinforcement learning, but at a very high level, the idea is you train a reward model to judge what is good and what is bad. How do you do that is you take the base model, you generate a few outputs. So basically the thing is, ideally what you want is that for a given query, what's a good output? But generating those huge outputs from humans is a laborious task. So what you do is you generate multiple outputs and then ask humans to label which is good, which is bad. And then you train a reward model which basically mimics this human preferences, and then you fine tune the base model using this reward model, and you get an instruct tuned model, which is at a high level the approach Instruct GPT paper follows.
So just to break the monotony a little bit, Amit, do you want to ask some questions on this just for edification of all of our listeners? And obviously this is the umpteenth time that I'm learning about this, but I'd love to learn some too.
So I think one of the things that initially I was very curious about was why train a separate reward model and not directly take the human preference data and directly train the LLM on it.
Right. Like I don't have a great answer to this, but what I feel like to train the reward model, you need less number of data points. And once you do that, now like after even the human preferences, after you have trained the reward model, now you can scale it up to even more data points, because now you have kind of a model which can mimic that human preferences. So you can generate large number of prompts here and see, okay, good, bad, and accordingly back propagate to basically fine tune this model. This is my understanding. Dheeraj, maybe you would like to add on.
Yeah, I mean, obviously there is a value in synthetic data here as well that these foundation models could generate, and then I could have it basically go through a lot that humans will just find it way more laborious to actually go through. I think human seed, but then eventually this reward model is the one that scales to a lot of synthetic data as well.
Yeah.
Right? I mean, do you think that makes sense?
Yeah, like that was my thinking too, is that you can scale the human labeling to a much larger degree in terms of training data for the LLMs. And that was the reason for going through
And by the way, tactically happy, does the Olama factory or all the tools around fine-tuning, supervised fine-tuning, do they apply to reinforcement learning as well? Or and differentiate RL from RLHF? I mean, tell us about that as well.
Yeah, I'm not pretty sure about that, to be honest. Like I have not went deep into RL. Maybe
Okay,
I
so
can't comment on
maybe in
it.
the next 3 to 6 months, we'll come back and have you actually show to people through, command lines, and we'll do a little bit of a Twitch-like session to basically do reinforcement learning on a model. Yeah, the
Yeah,
date is completely up to you. Okay,
sure.
great. So yeah, keep going, please.
Yeah, so until now we saw how LLM training worked, where you trained it for alignment with human preferences. So now you can ask it a question and it can generate an answer. When I say generate an answer based on the all the knowledge of internet it has learned with the data it was trained on, not any real time question answering until now. The next step comes in, which started from Meta. I guess it started from Meta with their tool former paper in, I guess, Feb 2023, where they talked about how to train these models to predict these tool calls. So in their paper, they had this, okay, the model is generating text. Now it decided, okay, here maybe I need to insert the actual year when this happened based on by looking into web or something. Then it predicted some, okay, I need to, in a some special syntax, which they trained the model on, that I need to call web search tool with these arguments. And whatever the answer might be, you just replace it there and you will get basically using this they basically trained the model to generate to interact with external world by producing these special tokens to say on okay I need to invoke a tool with these arguments. And then from here, the entire wave of function calling started. So in one of the post-training fine-tuning stage, model providers also fine-tune it for structured output generation. So basically training it to generate a valid JSON. There was a lot of different things that came in this time period from Llama CPP, from there is this one thing called context-free grammar generation. You basically restrict the model's output token on basically what it can really output so as to generate a valid structured JSON, for
constraint
example.
decoding.
Right, correct. So that started, and then on this function calling piece from Berkeley University, there was this paper called Gorilla, where they trained an LLM on, I guess, some 10,000 plus tools to generate these, basically create a tool calling LLM. And then they also created this function calling leaderboard, which is like, because of lack of much better leaderboards, it is the only leaderboard which people right now compare against, and some have their own internal versions. So which has multiple versions of like, okay, whether or not like they have a problem set and they then see which model produces the right tools for this data set. And then they have multiple variant of multi-turn tool calling and so on. There is one special tidbit I read from someone on Twitter the other day that function calling, like if you see all these different API providers, OpenAI, Anthropic with these function calling, all they ask you is, okay, you provide me the name of the tool or function and the input schema. there is nowhere a mention of output schema, for example. So function calling inherently is optimized for one step prediction. Basically, okay, given this task, this is what I need to do first. Once that is done, then I can decide what I need to do next. Because like you can't initially itself determine these are the two tools I will call in this order, because you don't even know what is the output format of the first one, for example. So that was a really interesting tidbit I saw recently.
So how does it work then? How do you take the output and then convert that to some form of an input to the next tool or the next step?
Right. So that's all, for example, happens in the LLM memory to say. So let's say you ask an LLM a question, I need to go to Paris. Can you check the weather and book me a flight ticket for tomorrow? So how it will do it is, first of all, and let's say you have tools for get weather, book flight, etc. So first of all, it will say, LLM will say, okay, I need to invoke get weather tool with the city or zip code, whatever the tool might expect. Once that, so as soon as LLM predicts that, so technically it is still text in, text out. So, and since it generates that structured output, that's where the model providers take that and return you in the API that, okay, what's the model has predicted this tool, and you provide me the next step, next output of this tool. So then you invoke that real tool, invoke that real API, you get the data out, and then you pass it back in the next turn of that message. That goes back to LLM, and this time, like to LLM, it goes from starting. This was the user message, this was the tool you predicted, this is the output of the tool. Then LLM does reasoning. Okay, the initial task was I need to get weather, I have done that. Now I need to book a flight. This looks reasonable weather to book a flight. If it doesn't, it might reply, oh, it is not a better weather to go. And if it looks a reasonable weather, then it will say, okay, now I need to book a flight, assuming it has all the information about the user needed to book that flight. So then it just invokes book flight tool with the corresponding arguments. Then it goes back and this process repeats. So if we take a closer look, what happened here really was the entire user task was broken down into n steps. And for each step, you designated, okay, here I need a tool call or don't. And then you execute them one by one. Like technically what I described, you actually just did one step, one step, one step, and then you decided what to do next. But in a different variety of models, which we have discussed, which you have discussed in the previous podcast on those reasoning models like DeepSeek, there you can generate a full thought process first. Okay, I will do this, I will do this, then I will do this. Oh no, I won't do this, then I will do this. And then you actually start really executing that process. That's a different variety, but yeah.
Good. So you've set the stage for what function calling means and how it's fairly simple and atomic in that sense and tactical. So that sets the stage for this paper, CodeAct. Maybe say a few words. I'm going to display the thing for the sake of people actually seeing the paper. So it's called Executable Code Actions Elicit Better LLM Agents. So yeah, provide your summary of this.
Right. So here, basically, if we revisit what we just discussed on the LLM and atomic tool calls, if you see carefully, it has a few limitations which this paper points out, which are basically constrained action space and lack of flexibility. What that means is, in the constrained action space, you can only, or LLM can only execute tools which you have given it. So for example, if you have just given it get weather and book ticket, it can only do that. And let's say now you were to say, oh, can you book flight tickets for each 5 different locations? These are the 5 different locations and these are the dates. Or it has to do it sequentially, one by one, one by one, one by one. It has no way of doing that looping or conditional thing unless it brings it into the memory and does that, or you provided tools to do that. So that is basically what authors call it, that in this JSON-based action space for this LLM agent, okay, maybe we can give a little bit hand-wavy definition of agent because industry has not agreed on one definition yet. So LLM agent for this paper, we can call it an it's a LLM which is hooked with some tools and it is interacting with user and an environment. Environment in JSON based, environment in JSON based tool calling or function calling is sorry, the actions that this LLM takes are in this JSON based action space for this function calling, and they interact with environment and user and get some observation are basically those tool outputs, and based on those observation it decides what to do next.
So I think,
So
Happy, you probably have to go slow again on this and maybe give an example of an environment. For example, these legacy systems could be the environment. So, provide some examples of user, agent, and the environment, and just go slow. I think this is actually a pretty important concept because everybody needs to understand user, agent, and environment fairly, well.
right. So user in this case, so first of all, let's talk about the agent. Agent is this LLM hooked with some tools or functions, whatever you might want to call it. User is the one which is interacting with the system, and environment is the one with which LLM is interacting when it says, I need to execute this tool. Whatever layer here is to execute these tools. For example, in let's say you are doing actual tool calling with these LLM based APIs, OpenAI APIs, right? So when I write this code to say, okay, LLM dot predict and given this query, now I am the user who is invoking this agent, this LLM based agent. Maybe not the best example. Maybe we can take a real world example here. Let me think. Right. So when you interact with chatgpt.com, you go on the UI, you interact with ChatGPT, which has access to this web search, which has access to and different tools, file upload and so on there. So now when I am typing something there, I'm asking it, okay, what is the weather in Paris, right? So I am the user which is interacting with this agent-based system. The agent-based system is this chatgpt.com, which has exposed this chat-based interface to me. And when I interact with this, then this behind the scene goes to the agent, which is the LLM powering this system. And then they predict, and they are interacting with the corresponding OpenAI servers. Basically, when the LLM predicts, okay, I need to invoke web search tool, it goes to the OpenAI, intercepts it, and actually invokes this tool. So web search is happening. Let's say it's a Google-based search, right? Google search engine. So that is acting as an environment, and based on your query, it gave you feedback, which are basically the results, and it interprets those and gives you back some output. Then
it's going to be very interesting if OpenAI starts using Google search for anything, actually. I wonder what they use, Amit. Do they use Bing APIs? What do they use for web search?
I think they have their own crawl. So they're much closer to Microsoft than Google, obviously. So I think, I know, for example, at least initially, Perplexity was using Bing APIs to power this LLM-based search. My suspicion, I haven't seen any public announcement. My suspicion is that OpenAI has its own crawl to
Oh,
power.
yeah. I mean, I know that. I talk to customers a lot when I travel the world, and they've already started to say that on their web servers, they're seeing half the crawler traffic is OpenAI. More than half many times compared to even Google. So Google has gotten a little bit tired of crawling now. Looks like, they want to walk and run, whatever that means. Walking and running. Good. So I think we talked about user, agent, and environment. So what's the core sort of idea of this paper?
Right. So what the authors say is like this JSON based or text based tool calling is limited. Like an agent which takes these actions in this JSON based can only do so much. What if you replace these actions with Python code, environment with a Python interpreter, and that's it. So basically, whatever tools you have, assume like those are kind of util functions present in your Python code. Now, when I ask the same question, I need to go to Paris, please check the weather, and if it is good enough, book me a flight. Now it can do entire thing in a single go by writing code. Okay, get weather Paris. If the weather is favorable, you can decide an algorithm for that, whatever favorable might mean for you. And if it is, just book the flight. You write this in one go. Now you are taking one single action rather than taking two actions or three actions to decide what to do. So what one flexibility you got was that you can do the same task in lesser number of interactions with the environment, first thing. And they also bank on, basically, authors talk about four major favorable things for this, their approach of CodeAct. One is that models in the pre-training stage are trained on a lot of Python coding data or just coding data, right? So models are pretty good at writing this code. So why not let them write code rather than making them write these structured JSON, which they learn in their post-training stage, which is on a very small, lesser number of scale. Second is Python as a language or any coding language for that matter provides this like Turing completeness in the form that it has all these looping constructs, conditional constructs. So all that thing you can do in Python in the code rather than doing it in the LLM memory one by one. So that's one another thing. And
So
third thing,
on that, how would you do loops? Like if I were to give a batch of work to an LLM and there was no Turing complete language like Python, how would I do this in an LLM? Actually, I've not been able to figure that out. Do I have
right,
to drive it one query at a time?
So LLMs can handle lists. So you can do a little bit of looping there without external sort of driver code. So like, for example, I can give it, so this is a favorite weekend activity of mine. I would go and say like, what are the movies that I can watch with my 13-year-old? She likes comedy and mystery and thrillers, and it'll give me a list of movies. And like, okay, for each of these movies, get me the IMDb score, get me sort of the first review and some summary. And so it can loop over the things in the context and do some
But
searches.
if I have to actually do some function calling for each of the rows, how would I do that?
Yeah, so that's what I was saying. Like, if it's a small enough list that LLM can handle, it'll just produce sequential code, one for each item in the list, right? And then you execute that. But if you want to reliably handle a large list, then
There's
much better.
the interesting observation that at least I've been saying in my own head about workflow engines, but Happy also brought it up in the beginning about Intel nodes and NVIDIA nodes and how you need to balance this hybrid cloud of nodes in some sense. It's like on-prem versus public cloud and how you really balance the two. So say more on that, Happy. Like, what does this mean? You have some Intel nodes running a Python interpreter and some NVIDIA nodes running the LLM interpreter. So what's the metaphor here?
right. So For example, on the other example I gave on, let's say you were to say book these five different, like for each day in the coming week, book flight for these different areas, right? Now for that, what LLM will have to do is one by one in its memory, like, okay, for example, let's say the places are Paris, SF, Slovenia, Mumbai, and Bangalore. Maybe you can't do all of them one by one, day after day, but let's assume. So what LLM will now do is, okay, I have to do Paris. So it will call get weather for Paris. Now it got, okay, what's the weather in Paris? Then it will say book a flight for Paris for this day. Basically, it is going one by one on each of the data point you provided and doing it by bringing all that data in the GPU, so as to say, in its own memory, and deciding, okay, now what I need to do next, now what I need to do next. The one limiting factor, a big limiting factor, to be honest, here is the context length of LLMs. We did not talk too much about this, but every LLM has a maximum capacity of number of tokens it can generate. And basically it includes the data that you are sending it as input and combining the data which is it is generating in the output. So if your list is big enough, right, it might exceed, for example, even the context window, assuming your API data output is huge, right? So bringing all the data into GPU memory for doing these sequential iterations is not favorable, so as to say, and not even reliable, because the amount of different, basically LLMs are also prone to this, so as to say, hallucinations. When you have a lot of conflicting data points, it becomes sometimes very hard to reason as well. Assuming the output is like, for example, when we were doing it for 5 different cities, right? Now let's scale it to 100 or 200 different cities. Now, when you are on 198 city, now whether the actual weather for this is this one or somewhere above, LLM can hallucinate and decide then mistakenly, okay, what I need to do next. So these
Also
are
for
like,
math problems, I mean, for very, very complicated, I mean, at least till about a year ago, I don't know if it's still true, that if you give it a very large number and say that even or odd, it actually is not good at saying that. Now, maybe with function calling now it can, but if you just base it on the original transformer architecture without using function calling, it wasn't good at those things if it hadn't seen that number. Is that still true without function calling, Amit?
Yeah. I think like complex arithmetic without function calling for LM is still pretty hard.
So how do they do all these AME papers, like AIME papers, and ASTAT with numbers better than humans?
No, those are like code generation and then code execution, right?
I see. So they're actually generating code just like this paper
Yeah.
talks about.
Yeah.
Interesting. So there's a commonality between some of those benchmarks and what this paper is talking about then.
Yeah.
Fascinating. Yeah, so keep going, Happy.
right. So like, as we said, CodeAct banks on these four benefits. Maybe we can first go to the table which these authors point out, and then come back here. Basically,
Mhm.
what are the real benefits of this code-based action approach, hence the name CodeAct, are these four: availability of data. As we said, models have seen a lot of this code in their pre-training data, so they are pretty good at generating code. Then these coding languages provide all these complex operations, for loops, conditionals out of the box. So models don't have to do this in the GPU memory, so as to say, and they can push this down to CPU or actual Python interpreter to say here. And then third thing also is like, when you are doing this actions via JSON, then you are limited by the tools you provide to the LLM. But here, since there are so many Python or even in the other languages libraries available open source, which these models have seen in their training data, so they can already reuse some of those. For example, if you ask it, oh, can you draw the price chart of XYZ company's stock in the past 10 years? Now it can get the stock data from an API, and then it can use all these different visualization libraries and do all kind of analysis just because it already knows, okay, how to use pandas and so on. So it can use those existing software packages. And fourth most important point here is this automated feedback. This is basically, and we have actually some good amount of things to talk here. So on the automated feedback, like a lot of these languages have these feedback statement built in for the users. As in, if you do something wrong in the language, you leave some indentation, you miss the closing semicolon, you miss the bracket. They have descriptive error messages on, okay, what is wrong with the code, right? And these act as a strong signal for LLMs to correct. Okay, maybe I missed this. Let me correct it.
You're
Some
saying
of it is
compiler as a machine is able to
right.
provide feedback. I don't need to have humans do this.
Correct, exactly. And
Mhm.
like one more thing, like from your one of the previous podcasts on this DeepSeek approach. Uh, so one thing I liked there was this reinforcement learning with verifiable rewards. The approach that DeepSeek pioneered, maybe OpenAI already used it, but anyways. So there, if you see what they claim is, and even in their paper, what they do is they say that code for code, you can really verify whether or not the output generated by LLM is correct. In the sense, you can have some heuristics of, okay, whether or not it passes test cases, whatever test cases you might have had, it compiles, the code compiles, and you can have some more things like that. And that gives a huge advantage to improve the coding performance of LLMs. You can like train it more and more, and you can verify whether or not that generated output is correct. So there you can scale a lot. So what I personally see is that these coding based LLMs are going to improve more and more in the
Mm.
coming years.
And then
So
what happens to this? I mean, Amit, you made the observation that in post training, looks like a lot of the benchmarks that they're acing is by CodeGen as well. So what's novel about this paper?
So I think there's a difference between code being the end goal versus action being the end goal, right? So a lot of the coding benchmarks are basically saying that if I
No,
go
but
ask
they're
the
also
LLM,
math benchmarks, that they're acing, right? Or they're math Olympiad benchmarks.
oh, so those are actually not about doing arithmetic. Those are about solving conceptual
Logical
problems,
deduction or induction and
deduction
things
and
like. Got
yeah,
it, got it. So you're saying if it's deduction, induction, they can still do it with reasoning
yeah, yeah,
as opposed to arithmetic, which they're still not very good at.
yeah, yeah.
Interesting.
Anything that requires doing lots and lots of steps very consistently, um, that's just hard for LLM to do without generating code and executing code.
One thing I remembered, and I was talking to you guys about this before as well, is like this idea of going from GPU to CPU for every little thing.
Mhm.
Like every action is now calling a function, another action calling a simple function. These are like API calls at the smallest level. Is very much akin to how, I mean, even if you go back to file system protocols, like, NFS introduced compound statements. It's like, hey, I don't want to go back and forth from client to server for everything. If anything, it's high performance uh, because, we know latencies of LLMs as well in this process. They're not in milliseconds or hundreds of microseconds, in that
Mhm.
sense. So going from GPU to CPU, back to GPU, back to CPU for every little thing has big performance degradation as well. No different than in file system protocols going from client to server for every little thing. So compound statements are created. I mean, even in the world of databases, stored procedures were like that too. Like rather Java SQL, Java SQL, Java SQL. You're going back and forth in all these network round trips. Looks like this has some resemblance to this as well. Like, look, rather than go from a GPU and a simple function call come back, another GPU function call come back. If you just gave this whole thing to the CPU and let it actually run it on the Python interpreter, it's probably great for reliability, but also amazing for performance,
Hmm.
right?
Yeah.
I think there's some lessons. I want to actually talk about a very important comment I actually left here, which is about MCP. So what about it? Like, if I am actually able to generate code, and then I can call a Salesforce API from within Python, and I can call whatever these packages are available. So is the idea of MCP where the LLM is calling individual functions, so tool calling, to an MCP server versus I giving it to Python, and now it's calling a normal API server of the business software system or legacy system. Are these things at odd with each other, or do they complement? Do they resonate? Like, what are your thoughts?
So, in my opinion, MCP is more of an exercise in social engineering than software engineering.
Man, I want to actually repeat that one more time because that's what our YouTube headline is going to be, when we actually come out with this episode. Say that one more time, actually, and
Yeah, I
please
mean,
double down on that. Like, what do you mean? What do you mean by that?
yeah, so what I'm saying is that MCP is more of an exercise in social engineering, getting everybody excited about building better documented, better usable interfaces than anything major in software engineering. I mean, it's a very thin convenience layer on top of what REST APIs already give you. It's basically a little bit of extra information about that API that's helpful for LLMs to understand what's going on there. But this whole sort of momentum and trend that has built towards MCP is very good for ecosystem because the push
People are
everybody
learning.
to
People
start
are
thinking
learning as
about.
well. Sorry, my lights just went off. I'm going to start to switch them on and continue. I think, what do you think, Happy?
Yeah, I think they're not at odds with each other, but mostly complement like this approach and MCP
You
in
think
the
both of them
sense
are
that
software engineering, not social engineering?
uh, yeah, I mean in the sense that like that is still social engineering, but it helps even models to know, okay, what code to predict now, how to really use those APIs. I think MCP is going to help with that, and that will in turn lead to like
But
this
why do I need
better.
to go to an MCP server? Because that's a different gateway, right? I mean, I need a layer of translation now. If I just enter the Intel CPU, the Python interpreter, I'm game like legacy systems, like normal software.
So let's say you wanted to, query some SaaS app, say HubSpot or something. I think what you would do is you first find the documentation for REST API. Then based on that and some example code, based on that, you'll generate some code against that REST API, right? And this is kind of a nicer way of exposing that interface where you have you've listed all the functions, you have the documentations as part of the protocol, and that's about it.
But realize what I just said about compound statements, because if I did it the Python way, this CodeAct way,
Hmm.
I would actually not be going back and forth GPU and MCP and GPU and like LLM and MCP and LLM. I'll just say, look, just take this whole thing and really think about something compound, which is a bigger molecule, which has logic and looping and conditionals and all this stuff. So then once I'm in Python, I don't need MCP, right? Or do I still need MCP because I still need to generate code for that HubSpot API call? But I could do that with normal sort of documentation. I don't need a whole protocol for that.
Yeah, I mean, like those REST APIs, like what I think is these MCPs, basically these are very much designed for LLM understanding, with all that better documentation and whatnot. I mean, technically, let's say if that were all those things were already available in REST API, which are not very LLM friendly, I would say, to be honest. I mean, technically, sure, LLMs have seen that much of these REST API spec as well in their pre-training data. But what I feel is like when you really explain with those few short examples, okay, what does this thing do, when to use it, when to not use it, these are the arguments and things like that. That really helps to like compose that code even better. So that's where I thought or I felt ki, this MCP would help to complement it. But do we need actually really a different protocol? That's, yeah, I'm not sure.
So I could easily have used, sorry, go ahead, Amit.
I was saying it's kind of the same idea that people say that in the last 2 decades, everything, all the web pages on internet was written for human consumption. And the fact that search engines were crawling it and giving you answers was just kind of side thing. Maybe SEO changed that a little bit. But in the next decade, a lot of content produced on internet will be not for human consumption, but for agent consumption, or like AI
crawlers,
consumption, so that we will get answers through these agents and LLMs, and these LLMs will go crawl these pages and read them. So the authors will write them in a way that favors.
I mean, and you kind of had that with SEO optimization, meta headers, the things that crawlers are supposed to read and stuff like that. So it looks like some of that is happening as well.
So similar thing, like REST API was created for human developer consumption, and the idea of MCP is for LLM consumption.
And maybe a little bit of reasoning traces or something, it's like that kind of verbosity that's also required.
Yeah.
Interesting. Very interesting. Any last thoughts on this? Happy, do you think we're going to use this at DevRev? Is this basically for edification or is this something for production?
Right. So one caveat that I see in this direct code execution is it's not very human friendly, like at least for non-code developer people. I mean, if you just give it a 200 lines of code that, okay, this is what I'm going to do, no one is going to read that to understand. And it might do that in loops, right? I mean, it might execute that code, that might fail at some place, it might rewrite that code. So that's not very human friendly to visualize what is happening. But if you see the concept, what the real concept is that rather than doing atomic things, you do molecular things by producing it in some kind of Turing complete language. So how do I envision this in enterprises? Is this, for example, these no-code workflows, which more or less are Turing complete in the sense they have all these looping constructs, conditional constructs, right? Those are very designed as human-friendly things. I mean, once you see those, okay, you are doing this, and if this branch, then do this, that is for human consumption. So if we can map the same problem, like rather than writing Python code and executing it within a Python interpreter, if we can map this to a, let's say, no-code workflow language and execute in that workflow engine language, that is something which I personally think we can utilize for enterprises. And that doesn't mean that we can't use things like these pandas and whatnot, other libraries these had. I mean, there are two benefits actually. You can still have a Python node there to do some simple things there to have you utilize those things. But the other thing is like in businesses, most of the business had have already created these complex business processes modeled as workflows, which act as these few short examples, even for the agent to generate new code or to say new workflows. So I think that is something which we can actually, which we might even use in DevRev. We are working on it. Yeah.
Any final thoughts, Amit?
Like, it's the thought that comes to my mind is that you want to give LLMs enough rope so that they can do interesting things, but not so much that they can hang themselves. I think there is this phenomena happening where a lot of, untrained engineers producing a lot of code um, just by asking LLM and just doing something and not thinking in terms of like readability, extensibility, and all kinds of other things. So there's that end of the spectrum. And then the other end of the spectrum is like if you try to button it up too much and you're saying that like the only thing you can do is take this JSON and call function, then you can't do enough interesting things. So there's some balance in the middle that depends on how capable the LLMs are. The more capable they become, the more rope we can give it. So
Yeah,
it's
I think the
spectrum.
to me, what gives me just a little bit better balance, because I always want balance of two opposites. So, I mean, when I look at the new workflows, I'm like, oh yeah, they're going to hybridize Intel nodes in these workflows with some, NVIDIA nodes. And for deterministic things that are prescriptive, we're going to use the Intel nodes. Intel is not going away anywhere. It just so happens that there's new tasks that Intel could never have done, which were probabilistic, that will actually use NVIDIA nodes for.
Yeah.
So for all those AI bashers who are like, hey, but it does hallucination and it's all, I'm like, well, use the Intel nodes for that. So I think we are finally coming to a world where these two things will actually coexist. Albeit, I think NVIDIA looks a lot more exciting. And maybe more and more of the Intel nodes will run on code-generated stuff by LLMs, so not as many by humans. But it looks like doing deterministic things and doing probabilistic things will actually find a balance.
Yeah.
And just this paper made me realize that, look, you don't have to go back and forth because, going to an LLM is also pretty high latency right now. They're not running, one of these things. Like, I mean, I used to think of, microseconds. Okay, we're going to take 6 cycles of Intel for, let's say, an instruction, and so on. And we were doing things in, microseconds as opposed to hundreds of microseconds and things like that. Right now with LLM round trips, I'm talking about, can I get it back in 2 seconds or something, So definitely we have to think hard about the round trip as well. But great find, Happy. I think this is, somebody was asking today, how do you learn? I'm like, I'm just forcing myself to a podcast to learn, because then I'm forced to read, and then I'm forced to prepare and things like that. So, really appreciate you doing this with us. And, just the clarity of thought that you got as well in all of this. I look forward to seeing you back. Maybe we'll do reinforcement learning, like just a tutorial, like let's do something which is live. And maybe at that time, talk about whether you used any elements of CodeAct for some of the things that we talk about here. Yeah. Thank you, Amit. And thank you, Happy. And looking forward to the next episode, Amit.
All right.
Thanks, Dheeraj. Thanks, Amit. Bye.
Bye. Bye.